Today we are going to be talking about some trig equation applications, and really we're just going to look at some examples of word problems that involve trig equations. So example 1, when batted, a baseball leaves the bat at an angle of theta with the horizontal and an initial velocity of v0 equals 100 feet per second. An outfielder catches the ball 300 feet from home plate. Find theta, given that the distance traveled, d, capital D, by the baseball is modeled by the following equation. Okay, so we have capital D equals V0 or V naught squared over 32 times sine of 2 theta. Now, for us, we are trying to find the value of theta, so let's plug in everything else that we know. So the initial velocity is 100, we can plug that in, and it says an outfielder catches the ball 300 feet from home plate. So D is going to be 300. So plugging that in, and now we're going to solve for theta. So we'll go ahead and simplify this as much as we can. So 100 squared over 32 is 312.5. We'll divide both sides by 312.5 to isolate the sine 2 theta. That leaves us with 0.96, which is fine because that's between 1 and negative 1. And now we're going to go ahead and solve for 2 theta. So 2 theta is equal to sine inverse of 0.96, since 0.96 is not a memorized value. And for this problem, we are going to work in degrees, just because we are working with measurements that usually, if you're talking about trying to figure out the angle measure for a baseball and a bat, you're probably thinking more in degrees. So we'll give our answer in degrees. So sine inverse of 0.96 divided by 2 comes out to be about 36.9 degrees. Okay, example 2. Owing to startup costs and season variations, Gina found that the monthly profit in her bagel shop during the first year followed an up and down pattern that could be modeled by P equals 2t minus 7 times sine of pi t over 3, where P was measured in hundreds of dollars and T was measured in months after opening. Part A, did Gina's bagel shop make a profit in its second month of business? Part B, did Gina's bagel shop make a profit after 1 year of business? Okay, so there are a couple of things to note before we get into the math here. So first, the equation that's given to you, P equals 2t minus 7 times sine of pi t over 3. If you see pi inside of the function, inside of the trig function, you'll know that we are working in radians. Another thing to note, P is in hundreds of dollars and T is measured in months. So notice how in part B it asks for the profit after 1 year of business. Just be sure that you are converting that into months before you plug that in. Okay, so part A, we are going to go ahead and say, okay, in its second month of business, that means when T is equal to 2, we'll plug 2 in for T. So we have sine of 2 pi over 3 in there, and then we have 2 times 2 in front. 2 times 2 minus 7 times sine of 2 pi over 3. Now we do want to come up with, I know we can come up with a very exact answer here for sine of 2 pi over 3, but let's go ahead and get an approximate answer because we want to know the actual amount of profit that's being made. So this comes out to be 4 minus 7 times sine of 2 pi over 3, which comes out to be about negative 2.06 or so. Now remember that this is in hundreds of dollars, so this is actually about negative $206.22. So to answer the question, did Gina's bagel shop make a profit? Well, no, because the profit is negative, so the answer would be no. Okay, for part B, did Gina's bagel shop make a profit after 1 year of business? So 1 year is 12 months, so now we're going to go ahead and plug in 12. Now for this, you actually don't need a calculator even to get an approximate answer because this 12 pi over 3 is really just 4 pi And we know sine of 4 pi is the same as sine of 0, and sine of 0 is equal to 0. So really you have 2 times 12 minus 7 times 0, so this is going to be equal to 24. Again, remember this is in hundreds of dollars, so the profit after 1 year of business is $2,400. So to answer the question, did Gina's Bagel Shop make a profit after 1 year of business? The answer is yes. Okay, example 3. Zoologist Zoe has been monitoring the weight of a panda at the zoo for a 2-year period. She has found that the panda's weight, W, followed fluctuating curve that could be modeled by the function W equals 220 minus 1.5 t plus 9.81 sine of pi t over 4, where t was measured in months after January 1st of the first year, and W was measured in pounds. Part A, what was the panda's weight at the beginning of the 2-year period? And then part B, what was the panda's weight at the end of the 2-year period? Okay, so at the beginning of the 2-year period, we're really talking about January 1st. So at the start. So how much time has passed in that case? Well, if we're starting on January 1st and at the beginning of that 2-year period, we're really talking about when t is equal to 0. So we can plug in 0 for t, and this is actually, again, pretty easy for us to simplify even without the use of a calculator. The 1.5 times 0 obviously becomes 0, and then we have this term at the end here, the sine of 0 pi over 4, that's sine of 0, and you know that sine of 0 is equal to 0. So everything here is, the second and the third term is going to 0 out, and that leaves us with 220 pounds for our weight. So at the start, the panda weighs 220 pounds. Part B, what was the panda's weight at the end of the 2-year period? So at the end of the 2-year period, again, make sure you're working with the correct units here. T is represented in months. So what was the panda's weight at the end of the 2-year period? You're really talking about after 24 months. So that would be 220 minus 1.5 times 24 plus 9.81 times sine of 24 pi over 4. And again here, the sine of 24 pi over 4 is really just sine of 6 pi, and sine of 6 pi is the same as sine of 0, which is 0. So all you have to do is 220 minus 1.5 times 24, and that gives you 184 pounds.